Hey y'all, it's me, Miss B. Today we're talking about identifying functions and graphing relations. So, let's go through these definitions. First up, a relation. A relation is a relationship between sets of values and ordered pairs. So, and our ordered pairs are going to be written as x comma y. A relation is going to be a function is going to be a relation that has one output for any given input. In other words, if you plug a number in for x, only one y can come out. All right, domain is the set of all x values, otherwise known as the inputs. The range is the set of all y values, otherwise known as the outputs. The vertical line test is, we'll get to that later in the notes, but it's going to determine if a graph of a relation is a function or not. Basically, you draw a vertical line, and if it intersects with more than a point, then it's not a function. All right, so a function rule is an equation that represents an output value in terms of the input. So sometimes we say y in terms of x, and you can put that in function notation. So here's a function rule here. We've got let's actually do y first. So we've got y equals 3x plus 1. That's a function rule as y in terms of x. We have f of x equals 3x plus 1. It's f of x is our output and f of x is our output and x is our input, and f of x is in terms of x. And then finally, this is our function notation. This is f of 1 is 3 times 1 plus 1. So this is our function notation. And that is f of 1 in terms of 1. Okay, the independent variable represents the input of the function, and the dependent variable represents the output of the function. And the best way to remember is the dependent variable depends on the input variable. All right, so let's go to do some examples here. So we're going to represent this function. Here we're given a discrete function. It's got the brackets, and each of those values are points in there. And those are written as x comma y. All right, and so we're going to represent it in 4 different ways. I'm going to go ahead and fix my graphs of these. So go ahead and scratch out those numbers. We're going to use different ones. There's another one down here, do the same. All right, so let's go ahead and put those values into a table. So we've got 0, 1, 1, 3, 2, 8, 4, 9, and 5, 10. Just putting them into the table. Easy enough. Then we're going to put them as ordered pairs. Now, they're already ordered pairs, but we're asked to write them as ordered pairs, so let's go ahead and do that. So we've got 0, 1, 1, 3, 2, 8, 4, 9, and 5, 10. We want to separate those with curly brackets. All right, here we have a mapping diagram. Usually our mapping diagrams have our domain and range or x and y values in them, and we don't want to repeat any values. So we've got 0, 1, 2, 4, 5, no repeats, 1, 3, 8, 9, 10, no repeats. So 0 goes to the 1, 1 goes to the 3, 2 goes to the 8, 4 goes to the 9, and 5 goes to the 10. All right. And then for our graph, we'll just plot each of those points. So here's 0, 1, 1, 3, 2, 8, 4, 9, and 5, 10. And we do not connect those points. This is not a continuous function, it is a discrete function, so we say that it is not continuous. Continue. I don't know how to spell that. O-U-S. Like that? I don't know. Okay, so let's talk about the domain and range. So domain is our x value, so I'm just going to look here and basically list those x values in curly brackets. So it's 0, 1, 2, 4, and 5. Again, we just list those values because it is a discrete function. The range is going to be our y values. Again, just list them. So we've got 1, 3, 8, 9, and 10. We want to make sure we use curly brackets and not any kind of other brackets because they mean different things. Okay, I want you to go ahead and try this next one on your own. All right, so we've got y equals x squared. So this is a continuous function here. Continuous. So we won't be able to list all the values, but we'll be able to list a lot of them. So first we have our table. So what we're going to do is we're going to take our values and plug them into this equation. We're going to plug our x in to get our y. So let's go ahead and do -2, -1, 0, 1, and 2. And so then we're plugging our -2 in. I'm going to show the work here, and then I'll end up erasing it. So we're going to have y equals -2 squared, coming from this equation right here. So -2 squared is 4. And then we keep going. So then I'm just going to do it in my head. You can type it into a calculator if you need to. -1 squared is 1, 0 squared is 0, 1 squared is 1, and 2 squared is 4. All right, let's go ahead and list these ordered pairs. So we've got our curly brackets, -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. Ooh, I forgot my parentheses. All right, so let's go ahead and do our mapping diagram now. It's going to be down here a little ways. So here we'll have our x and our y. Remember, we don't want to repeat any values. And 4 and 1 are repeated, so we'll only put them in there once. And our x values, we don't have anything repeated. So you have 4, 1, 0. Let's do 0, 1, 4 just to keep it in order. And we want to draw our lines to where they go. So -2 is going to go to the 4. -1 goes to the 1. 0 goes to the 0. 1 goes to the 1. And 2 goes to the 4. All right. And then finally for our graph, we want to graph this. We are a little bit off the graph, so let's just extend it this way a little bit. There's -2 and -3. So we have -2, 4, it's about right there. -1, oh, that was too far over. -2, 4 is about right there. -1, 1 is here. 0, 0, 1, 1, 2, 4. And it is continuous, so we need to put arrows on those ends there. All right, let's talk about the domain and range of the function. They're on the next line, but you can, I think they're on the same one for you. So the domain is our x values. Now it's a continuous function, so our domain is going to be, there's infinitely many numbers in the domain. So for the domain, you can see that it goes from, it just keeps going up and up and up. No x values can be excluded, so we're going to put all real numbers. And for the range, you'll notice that our values stop right here. So it's going to go from 0 up top. So any x is greater, or sorry, y is greater than or equal to 0 for the range. Okay. All right, so again, a function is a relation in which each element of the domain corresponds with exactly one element of the range. So we're going to determine if these relations are functions. So look at this first one here. We are 1 to 1. Each of these values goes to one thing in the range. So -3 goes to 1, 0 goes to 1, and 4 goes to 1. Because of that, yes, this is a relation. Yes, this is a function. Okay, so basically we want to see if there are any repeat x values. We can't share any x values. So for this one, we've got 4, 8, 1, 6, and 4. Now because of that 4 being repeated, and they don't share the same y value, no, this is not a function. Okay, go ahead and try the next one on your own. You'll notice that this 2 goes to both the 3 and -3. Because of that, no, this is not a function. Go ahead and try the next one. So we don't have any repeat values. We have 7 and -7, but that's it. So yes, this is a function. All right, go ahead and circle the ones on 5 that are a function. All right, so you should have selected just C. So for A, you can see that the 0 is splitting off in 2 directions. Because of that, it is not a function. For this one, we have 2 values that are shared on this line here, so it is not a function. And then this one here, even though we have 2 values that go to the same place, it is still a function. We just can't have it go the other way. All right, now let's talk about, forgot to write no, and yes. Okay, so using the vertical line test, we're gonna figure out which ones really represent functions. So we're gonna draw vertical lines, and wherever there's a vertical line and it touches in 2 spots, it is not a function. This is very clearly not a function because it touches in 2 spots, here and here. So this is not a function. This one here, no matter where you draw the vertical line, it's only touching in one place. So because of that, yes, it is a function. This last one here, if we do the vertical line test, this line goes through 2 points, so no, it is not a function. So go ahead and select the ones on the next that are functions on your own. All right, the circle is not, goes through 2 points. B is, And also C is. There's no place where it touches in two places. Okay, so function notation is just basically a fancy plug and chug. So basically it's saying plug these values in to this equation right here. So we're going to do f of -3, f of 0, and f of 1/4. So what we're doing is we're plugging those values in to this equation. So this would be -2 times -3 plus 5. F of 0 would be -2 times 0 plus 5. And f of 1/4 would be 2 times 1/4. Oh, -2 times 1/4 plus 5. So go ahead and solve each of those. All right, I'm going to show you work on these. We have to follow PEMDAS. A lot of people have been forgetting it. -2 times 3 is 6. And then 6 plus 5 is 11. F of 0, -2 times 0 is 0. Plus 5 is 5. Finally, we have -2 times 1/4 is -1/2. Plus 5 is 5. I'm sorry, not 5. 4.5. All right, keep in mind that this f of is not the same thing as f times. This is just f of. It's not multiplication. It's just a notation. All right, so go ahead and do, let's do A, and then we'll be done. Okay, so for A, you should have plugged in f of -2. So we have -4 times -2 plus 1. Following PEMDAS, -4 times -2 is 8, plus 1 is 9. So f of -2 is 9. All right, I believe that is all for today, folks. Let's just talk about what we learned today. Today we learned how to represent a function, or I'm sorry, not represent a function, represent a relation 4 different ways. We learned how to determine if a relation is a function. And we learned how to write in function notation. All right, that's all for today.